Welcome to Algebra 2, Unit 3-5. How do we add and subtract polynomials? You guys already kind of know this with simple polynomials, but I just want to run through it real quick for you so that you realize that you're capable of it. So, for example, here would be a polynomial. This is a 4-term polynomial. This is a 3-term polynomial. The only trick is make sure that you line up your like terms, and always pay attention to what the sign is in here. If there is no sign and the parentheses are side by side like that, then you're multiplying. You'd have to go to a box method. If your sign is in there, obviously you follow that. If it's addition, you're going to just add your terms together. If it's subtraction, you'll be subtracting, and I'll show you that on the next board. So here what I do, I just showed you my example. I take each term and I just write it below the term that has the like variable. Now I notice that I just now made a mistake because that's a 5x squared and I put the x squared under the 3x cubed. So I will erase that and I'll change that to being 5x squared right here under the x squared, and the negative 6x should go underneath the 9x. So there won't be an x cubed that I'm adding there. Now I would go ahead and just add them together. 3x cubed plus nothing would be 3x cubed. 5x squared plus 12x squared would be 17x squared. Do not add their exponents. You only add exponents when you're multiplying. 9x minus 6x, because it's a negative. So when you add a negative to a positive, you're actually going to subtract. Take the smaller one from the larger one and give it to the sign of the one that's farthest from 0. So 6 from 9 would be 3. The 9's farther from 0, so it's a plus 3x. 6 plus 7 is 13. There's my answer. If we're subtracting, what I do is make sure first of all that you write them in standard form. That means the highest exponent first. So I have 9x squared. Then I would have the 2 way over here because I need a spot to have the x to the first value. Since I'm subtracting, I just go ahead and I take this second polynomial and I write it right underneath just like it is. Negative 6x squared minus 2x plus 1. But before I do anything else, I show, hey, this was a negative, and now I distribute. You could have distributed up here and changed the other sign, but I do it down here out of convenience. So now I say, okay, subtracting is just like adding the opposite. So I make that plus, and I switch all of these in that second parenthesis to the opposite of what they were. Okay, it's just like distributing that negative 1 through each of those. Now I just add 9x squared plus 6x squared would be 15x squared. I have the 2x, and I have 2 minus 1. That's my final answer. Okay, we have a word problem in this one from the U.S. Census. The number of male high school students enrolled in high school in the U.S. can be approximated by the function. Now, the way they got that is they took data on it, they entered it into their calculator, and then they did a regressive formula. So that's how they got that. X is the number of years since 2000. So that's how they get the X. And MX is the number of male students. Then they turned around and they did an approximation with female students. So f of x, this equation is for females. Now it says approximately how many students in high school in America in 2007. So they took their male population and their female population, or this is what I did to solve it, and I got a total population by adding the like terms together. So that's the total. Now, they said, how many students in 2007? 2007 is 7 years from 2000, so I plugged the 7 in there, and I plug it in for each of the x values. I put it in my calculator. I could do nested form. I don't because it's just a big ugly number anyway. And I get approximately 17,100,000 high school students, male, female together. My question for you is how many students are there now? Okay, go ahead and calculate that. We want to see what the increase has been. Okay, that's the end of that unit. See you in class.